Okay, so I want to do what is clearly a Lagrange multipliers problem from 15.3, which is number 4. It's clearly a Lagrange multipliers problem because I can read, and the directions say use Lagrange multipliers. If I couldn't read, how would I know that a problem that looks like f of x and y is x cubed plus y on 3x squared plus y squared equals 4 and includes the word maximize?
Some optimization problem on that.
Right? Because there's a word that says optimize, maximize. There's a word that ends in eyes. And a function and also a constraint. Anytime you have a function and a constraint and a optimized word, you should be thinking Lagrange multipliers. You could alternatively do a Calc 1 style optimization. It will probably suck really, really bad.
I know this is nitpicking, but that says maximite.
Yes.
No, it says maximize, it's just messy.
It's not the scale.
Someone has clearly applied a nonlinear transformation to my handwriting. Whatever. Okay, point is, I like that you pointed out that it was a math joke, as though I was capable of making other jokes. I guess I make one other joke fairly consistently, which is that I'm an idiot, which I'm not sure is a joke. Okay, so how do you do Lagrange multipliers? Do you guys remember how this works?
No. Don't you take the gradient? I have gradient of time.
Good. Thank God. It's an optimization problem. Take the gradient of some damn thing. Right?
Whichever one.
Yeah.
Like, it's optimizing. Think Calc 1. Take a derivative of something. Right? I don't know, I'm panicking. I'm going to take the derivative of everything. And really, actually, this will work. So take the derivative of x cubed plus y. Well, take the gradient of f, right? So what's your x derivative for f?
3x squared.
3x squared. And your y derivative is 1. Perfect. I took the gradient of something. Yes! I'm accumulating points at a very good rate. Okay, now what else am I taking the gradient of? What's that?
9 more to go.
Oh no, this is 2. That's 2 for sure.
Let's go out
One.
G, I guess.
Go by 2 at a
20% of the way there. Now, I need the gradient of,
This circle.
yeah, the constraint. That's, yeah, an ellipse, not a circle.
Okay, sorry.
Squishy.
I'm willing to give you that it's basically a circle. So what's the gradient of G? I'm really looking at this thing and thinking that guy is G, right? That was the worst bracket ever.
I've seen this, don't worry.
Sorry, you can't tell I've spent 10 years practicing brackets. It's been longer than that. Okay, so what do you get for the gradient of G?
6x and then 2y.
You get 6x and 2y. Okay, good. 40%. Go. What do you do with those?
Gradient of f times lambda gradient g.
Good. So take one of them, set it equal to some constant times the other one. Okay?
Which is 3x squared.
Yeah, that's actually 6 points. Because you're doing Lagrange multipliers and you seem to know what you're doing, which is a big plus, even if you can't solve anything. So, now what do you do? Distribute the lambda, so you get 3x squared is 6 lambda x. That's out of the x components, right? And out of the y components, you get 1 is 2 lambda y.
It's so weird that you do 2 lambda y. I don't know why you put that in between the 2.
It's because I'm well trained.
Is that helpful in some way? I think I may have asked you this already.
No, it's not helpful in any way. It's just that I write everything in the standard mathematical notation.
Always have your constants up.
Which is you do constants out front, then So you do like integer constants, algebraic constants, transcendental constants, then variables in Greek first, then regular in alphabetical order. And if you don't know the Greek alphabetical order, you just guess.
Yeah.
Usually I do the bigger ones because I don't actually know the Greek alphabetical order. So anyway, I have this shape. Now, I am at maybe 6 points. So maybe 7.
Hold on, let's see.
What's the other thing I need?
Well, you need your constraint function.
Yeah, so you have right now 3 variables and 2 unknowns, right? So you need to remember that you have a third equation. Sorry, I said 3 variables and 2 unknowns. And what I meant was 3 variables in 2 equations. There's a third equation kicking around. Where is it?
G.
Yeah, it's that constraint thing you started with, right? So you need to take these 2 pieces and that constraint and utilize them somehow.
Well, let's find one.
So what do you do here?
Or
Solve for
I
lambda?
would solve for y for x.
Okay, so solve for something.
we can get X and Y in the same equation.
Would you just put maybe 6 times x where 3 lambdas and G?
That's an option. You could do that. So like this part is that part, right? So I could take that and cram it in up there. Sure. So there's a little creativity here, and I don't want to stifle your creativity, so do this somehow. So I'm going to go with Brailer's suggestion. So we're going to do 6 lambda x plus,
I would solve for y in the other equation.
oh yeah, so we need to figure out what y is, right? So y, it seems like, is 1 over 2 lambda. We get 1 over 4 lambda squared here. And that's supposed to be 4. Crap. Right?
So,
Yeah, so now I need to solve for x, maybe?
Probably don't care about that.
Right? Because I probably don't care about lambda. Okay. So I got 6 lambda x is 4 minus 1 over 4 lambda squared. And then I need to do, okay, so I got x is 4 minus 1 over 4 lambda squared over 6 lambda. Shit.
That's a really terrible thing.
Right?
And plug that in for Y.
So, and then plug that in for where?
I can see that. Jesus. Wait, do something.
So you could plug it in for both sides here, right? And then you'd have, but you'd have one equation with just lambdas in it. That'd be great, right?
Maybe.
Except I don't give a shit what lambda is, right? You guys see that? Like lambda is the thing that doesn't matter. So really I would like to get rid of the lambdas. You guys all see that?
Okay.
So it might be best in the beginning to solve for lambda and then equate those 2 things. You guys see that? Like find a way to eliminate lambda as early as possible if you can. So in my view, I'm going to go back here and be like, okay, maybe, how do I solve for lambda there?
Lambda equals 1/2 x over 2.
So 3x squared over 6x should be lambda, right? And lambda in this guy is 1 over 2y, right? So then I could do like, okay, so that's 1/2 x is lambda, and lambda is 1 over 2y,
It's pretty easy quadratics.
right? So then I could drop the lambda, multiply both sides by 2, and get x is 1 over y. You guys with me on that? And then take that and cram it in up there. So into your constraint, I think you get, you go find a new spot. I'll go right here. Ew, why am I doing boxes? Horrible. So I got 3, 1 over y squared plus y squared is 4. Right? Uh-oh. So, how do you solve that?
If you plug in y for lambda, you get a nice quadratic.
You plug in y for lambda.
You solve lambda in terms of y, and then plug that into your 3x squared.
Yeah, I'm going to get a quadratic here too.
But this one's so much nicer.
I have a nice quadratic here. You guys see the quadratic I have here?
It's just gross.
It's not gross. Multiply everything by y squared.
Oh, okay.
Get 3 plus y to the 4th minus 4y squared is 0. Then factor. Right? Or apply the quadratic formula or something. And the point is, figure out a way to solve. That creativity can be hard. It really can be. That's okay. That's actually one of the hardest things we task you guys with in here. It's not so much memorizing and then regurgitating a way to do things, but that little bit of creativity is hella hard. So solve this somehow. Like, sort out a decent method for the problem you're looking at. And if you go a little ways down something and it seems terrible, you don't have to commit to it. You can go back to the beginning and try something else. If you've tried 3 things and they're all horrible, just write solve. Big arrow that says solve with magic or something. Right? So in the end here, what did I get? I got y is plus or minus the square root of 3, and y is plus or minus 1. What also should I be careful of? So I pulled a couple of things here that I maybe ought to be thinking about.
That lambda, like we assume that they're the same lambda, right? In the 2 equations?
No, that's fine. I just, at some point here, I divided both sides by y, right? And at some point here, I divided both sides by x. So that should cause me concerns about what if y is 0. So if y is 0, 1 isn't 2 times lambda times 0. Okay, so the y is 0 isn't causing me any problems. I can pitch that one. If x is 0, well, that guy works. You guys see that?
Oh.
So maybe I need to also concern myself with x is 0. So in the end here, you're going to get kind of a whole bunch of little points, right? And so I've found these ones, like plus or minus root 3 and plus or minus 1 for y. But also x is 0 is apparently something I should be interested in. So I have all these points that I have to kind of keep track of. And I just want to know if there's a corresponding x, right? So like, if x is 0, does one of these equations tell me something about y? So if x is 0, right, then y squared is 4. So that would be y is plus or minus 2, right? So is that going to work with this 1 is 2 lambda y? Yeah, I mean the lambda can compensate, right? If x is 0, have I specified what lambda is over here? No. Okay, so that one works, right? Y is plus or minus 2 makes really a pair of points I have to deal with. You guys see that? Like I'm just checking whether I violated anything with these. So this guy's okay, that guy's okay. The lambdas are different, right? But that's fine, they're allowed to be different. How about when y is positive the square root of 3?
I'm sure you can still compensate.
So I'm just checking the constraint, right? So I got 3x squared plus 3 is 4.
So it has to be like the square root of 1/3.
Okay. So I find out that x is plus or minus 1 over the square root of 3, right? And then I just want to go think, like, okay, if y is the square root of 3, that specifies lambda. Oh yeah, it seems like that's working, right? It should work, because I solved for it. So I get 2 more points out of that. I get 1 over the square root of 3, and y is the square root of 3, and x is minus 1 over the square root of 3. Okay, see that? What are you going to get for the other one? Y is minus root 3. Same x's. You get x is 1 over the square root of 3, and oops, y is minus root 3, x is minus 1 over the square root of 3. So there's a whole crap load of points here, right?
Yeah.
Then I got y is 1. If y is 1, what's x?
Also 1 plus or minus 1.
Yeah, it seems like plus or minus 1. So y is 1, x is 1, y is 1, x is minus 1. Also seems to work. And
Same.
same thing. Whew. Lots of points. Once I find all these points, what are these guys telling me?
Those are, isn't that like heights of f and x, y?
These are other critical points that could possibly be.
Yeah, so these are kind of the critical points, right? So how do you tell which one's the maximum?
Test them all.
Plug them all into f of x and y, right? You guys see that?
Oh boy.
So that's not so hard though, because it's just x cubed plus y, right? I know, there's so many, but it's still not that hard.
So
So you get 0 plus 2 is 2. 0 plus negative 2 is
-2.
negative 2.
So you want
1 over the square root of 3 cubed plus the square root of 3 is good. 1 over the square root of 3 cubed plus the square root of 3. Which is ballpark bigger or smaller than 2? I don't know, about the same. On this guy, you're going to get the same thing, right, except with a minus. So you get minus 1 over the square root of 3 cubed plus the square root of 3.
is just smaller.
You guys see these? So you just keep cranking. Those ones are similar. This one is
2,
2. This one is
0.
0. This one is 0. And this one is,
-2.
I think, negative 2.
Yeah, -2. So there's 2 maximums.
So it seems like, yeah, it seems like the maximum is 2, right? Because you guys said this was just a little smaller than 2.
Just the lids.
Okay, so this has 2 maximums, and they are at 0, 2 and 1, 1.
Question.
Okay.
So on the test, would it be considered okay to not compute all of those, but just use kind of visualization of how these curves actually go to realize that negative x values and negative y values are not going to be the maximum in this case?
Totally. You can rule a bunch of these out, right? By noticing that this function's decreasing in the x and decreasing in the y, right? So if I want to maximize, I can make my life a little easier by being like, hey, the ones where you went negative in one of the directions, those aren't going to help,
So you just
right? So you can toss this out of that pair, right? And out of this pair, you can clearly toss this one.
both of them.
And out of this pair, you can toss this one.
Or, no.
You guys see that? So you can kind of go through these and pitch some of them. Like, that one ain't gonna work, that one ain't gonna work, that one ain't gonna work,
And then the negative 2.
and then the one with the negative 2 ain't gonna work. So then I'd have to evaluate those two maybe, just to check which one's bigger. They didn't have to be the same size, I just got kind of lucky on this. You guys see that? So yeah, you can use a little geometry.
Yeah,
So-
So you could draw some level curves, right? Which is really what Lagrange multipliers does anyway. You guys see that?
So would the answer be just a coordinate and you put it in a box?
Yeah, so the answer should be something along the lines of the maximum is 2 at the point 0, 2 and 1, 1. And really, if you were being totally precise, you would write, instead of the max, you would write the max.
Maximized?
It's an output, right?
Okay.
So that would be a maximum value of f, subject to the constraint is 2. Is all with me on that? Okay, cool.